start. So last time I came here and did some live demo, but who here can remember what we did last time? Can you remember? We wrote a sum function, right? I showed you guys how to use exorcism and yeah. Get started on string and array. But did we think about sort of what are the questions you ask yourself when you prepare for interviews, when you make yourself a better interviewee, right? You answer questions better. So I have 3 tasks today, and we'll go through each task, and I challenge you to think of all the cases that we can learn better. First task, write a sum function. Now everyone can do this, right? And so let's write it. When you ask this, so task 1, right? Think about a statement that you can write as short as possible. So when someone say, "Oh, can you write me a sum function that take a bunch of elements and return, the total of it?" And so your job is to simplify that. So I'm gonna try. I write something like, write a function that takes a list of numbers and returns the sum. So if you can come up with something better, shorter, you're even better, right? So that's a start. And we talk about how we should, before we start, we should tell the whoever, an interviewer or anyone, just yourself, what are you going to expect? So in this case, I say, hey, cool, I'm going to write a sum function. I'm assuming that you're going to just take a sum over integer. Let's just do integer for now. And I'm going to be able to test writing a sum function after I write it. I should be able to sum no element, 1 element, 2 elements, and so on, right? Well, obviously right now there's nothing returned, so I need to make it work. So I know that it has to return something. And so I'm thinking, oh, I was returning an integer. I'm using Playground so we can see the result very quickly. So now I need to make sure these 2 cases return 1. This returns 0. This return 1. This returns what? 3. So let's keep shouting out. So how do we make this work? Var s0 and then? Okay, we do now everyone already know this, right? I think when I ask, most people will give this answer. So we have to push ourselves to be more impressive than this. How can you be more impressive? You have to start asking questions. So if you have a pen, you take note. These are questions that you should ask. First, do you know the input size? What is input size? The size of the input, maybe how much memory and how many elements I have to read. What's the input size here? 0 or 1, however you think. Maybe it's 1 array or 0. What's the input size here? 1 here, 2. So already can you tell me how to improve more cases for me to test? Can I have a better input size? That's the first question. So then you learn how to do how do you generate a big input size? You use an array, right? A range, you convert an array into an array. So when you do this, your print will be, no one told me that my test never passed. Does it seem correct? So first think about what is my input size. All right, then you think about input size, then you ask yourself, can I think of better test cases? Better test cases. Can someone give me another test case? Another test case, Javen?
You can go max.
Huh?
You can go maximum.
Maximum. So input size and also very big input. They're different things, right? So is my input size big enough? So that was a big one. So for example, if you multiply this, you do this and it still returns some good result, and that's testing it with a really big input size. Unfortunately, it seems a little slow. Uh-oh. We'll talk about that. All right, so it's over here. Next, Javen said, let's do a large enough input. So if you multiply it, if you add two numbers together, what should this be? 0. It seems good. If you add it with 1, what's the total? With the same thing, but if you change the number, the order. So it's very important to be aware of when it goes wrong. So can I break my function? So I just found out a way to break it. So that's the third question. Can I find an input big enough to fail? You don't have to be, super smart to know how to solve this yet, but first you have to know it. So when you think about it fail, then you can say maybe you mention it. Some interviewer will say, can you write this function that must not fail? So how do you define that task? Task 2, well, just 1A, 1B. I'm not going to do this one. Write a function that takes big numbers but within limit, right? And return a sum, but we know that the sum is not too big, right? Some human function terminology like that. Does anyone know how to solve this problem very, very shortly? This case, Javen? Take numbers. If you add A and B, it may be too big, but when you add C, it may come back small again. A good example I have is, let's say I have a maximum of $1 million, right? And then you owe $1 million, you owe $1 million, and and I have $1 million in total, and you have $1 million. In total, 3 of you only borrow me $1 million. But if I add in the wrong order, it's overflow, right? If I go to you first, collect 1 million, go to you, collect 1 million, we don't have enough 1 million in the room. So how do we solve this problem? This is just a very quick one. So let's say if I sort the array, and then this get run, hey, it works. This is not how you solve it, but just lucky in this case it worked. Yeah? So can I find it big enough to fail? That's the third question, right? And in this case, I give a hint. So let's say if you sort all the numbers, if you add the first number, the last number, the second number, the second last number, maybe it's better, right? Explore that yourself. Now, you realize that every time I run a function and I test, how do I know that my function is still good? You have to look at every single line, right? Down here, you have to look at 0, 1, 3, is it still good? So then what if you have like 10 test cases? You have to read every single one. So what's the solution? Can I write tests better? So I'll show us how to write, follow a test-driven approach. What if we do something like this? We have, I'll use something like Xcode test. Who here has used Xcode test before? XC test? So we all can learn a bit today. So normally you name the name, put the name of the class and then test, XC test case. It goes like this. You can say test sum, and then there's an empty case. So what should you test in this empty case? I'm doing test-driven development right now. So I'm like, oh, okay, so you're testing my demo class, right? And then maybe I have a sum function and I pass in nothing. It should return 0, right? Now you look at the error. It say, well, unresolved demo. So how do we make this not crash? We define a class demo, right? Oops. Then we look at the error again. This is error-driven development. Also, of course, test-driven development. So one thing to learn about testing is you write assert, but Xcode give you assert. So you can use XCT assert and then a Boolean expression. But a better one is called equal. So I say 0 if I expect demo.sum. So if I do this, what do you think the error is? Has no member sum. So how can we make this pass? Red, green, but too bad this is all black. How do you make this pass? Define a function sum? But is it enough? No, right? Because then you have to do demo like this. Well, right? But then an easier way is that, well, it's the same in all cases, all instances, so I call static. Now you say argument is wrong. It takes one argument. So let's take one argument. Let's take a list, a list of integer. Then you look at the error again. Don't be afraid, right? Ignore all the stuff down here. Just look at the first line. Cannot invoke type this with this. Oh, it expect the second guy to be an integer. So I need to return an integer. Then what's next? Missing a return statement. So I return 0. Hey, what's going on? All seems to compile great. So now I'm going to show how you run this test. Just demo test is a class of XT test case. So just remember this one. You can get the test suite, which is just a list of a collection of all tests, and you say let's run them. And then when you run, you get the result. Test run is an optional class, but you know you already ran it, so I'm just gonna force it. And in this run, hey, look, done. Test suite started, and you see how much time it took to run, and then you have one test pass. Does it make sense so far? Test-driven development. Can someone give me another test? Func test sum. Now think about this. Empty, single. Give you a few keywords. Empty, single. How do you test a single case? Assert equal. How do you test a single case, guys? Demo.sum. Just one element, like that. But what should the result be? First, you make changes and you see, oh, okay. Should it be like that? No. It should be 1. And then it failed. And read this line. 1 is not equal to 0. Helpful, right? How do we make it pass? We now are like, in this case, well, I know what it is. Again, S is 0 for I in list. S, I, return S, etc. Oh, looks good, right? I executed 2 tests, 2 failures. Can someone give me another test? Test sum. Let's test a normal situation. You can call it maybe test simple. Empty, single, simple. And in this case, I'm going to pass in 1, 2, 3, etc. Right? What should the expectation, the result be? You put here's the convention. Just put what you expect at first, right? 6. So now you want to test a longer case. So maybe you can say test some range. And now this is getting interesting. You can test maybe 1 to 10. So you convert a range into an array and then sum it. All of them seems good. Can we not, if this part is clear so far? So what are the questions we asked so far? Do I know the input size? Can I think of better test cases? Can I make the input big enough to fail? Right? There's one more. Input size. Can I make the input size large enough to fail? Large enough. So remember when I put 1 to a million just now, it just keep running. Seems really slow. That's a different kind of test. I'll get there, right? But we fixed one problem. One next question. Do I have to look at every line in the log? Do I have to look at each one of these? No, I just look at the last line. Yeah? So here's one extra thing you can do here. You only need these two lines, right? Just even one line. But here you can even say print. I ran, so maybe this is a new line. I ran, maybe run dot execution count test. So you can actually print some extra statement. Like I ran 4 tests, something like that. And with maybe maybe it's nice to just see how long. There's a total duration here. So if I just let that in this number seconds, right? And maybe it's important with how many failures. So you say run dot failure, I don't know, I'm just guessing here, failure count maybe. But total failure count. Alright, you see this is failures. So of course I'm writing it here, but you can write a function Wait, Phong, you wanna move a bit, move over here? I want to make it fun. So you can write a function that checks the total failure count. It's like, hey, alert, test failed. Other than that, you can just keep coding, right? So that's cool. Then you're like, okay, so I have this, but now I want to test how slow my function is. Let's test how slow it is. This demo test, I test how correct it is. I'm going to show you how I test how slow my function is. So what if I comment this out, but I'm like, do I add more function here? Or do I create a new class? Maybe I create a new class. I call this like performance test, right? Inherit from XC test case as usual. And then maybe I can do this. Test, remember the same thing, test sum empty. And maybe I can say the second function test empty, we already test. Maybe test 1 element. And I say test 10. Maybe use number, right? 10. Function test 100. Function test 1000. Something like that. I have to run these tests. And then so I can see how slow my test is. My function is. So how do we run this, guys? Change the code down here, right? Let's learn something new. You can change this to performance test. And then it will run. And obviously I have no check in there, so all passed. Let's start again. Well, I don't like having to change this each time. Let's extract all of this into a function. Okay? What is this function taking? What is the argument? Run test suite. So I just say run suite. So test suite is a collection of tests. What is the argument? The class name? Yeah? So I call this test class. What is the type? You can maybe say any class. But technically, I know what is performance test, right? Performance test is an XC test case. So, XC test case. Now, you're lucky. You're using Swift, one of the most beautiful language. It's not just that. Well, this is a class name. It's not a class type. Swift will complain. I declare this function, and Swift will be like, hey, man. Okay, it hasn't complained yet. Let's put all of this in here. So I comment this out, right? So let suite equal test class dot what is the thing? Default test suite, right? It's not here because it's not a test type. You know how to solve this problem? You don't pass in the test name, you pass in the type. So now, default test suite. Hey, it works. And then the second thing we do is suite dot run, same deal. So I'm just gonna copy these guys. This is tricky to run that. So now how do you run this? Run the demo, the original demo test, right? And it will run. It will complain. Why does it complain? Or it complains the argument things. Again, it runs. It works, right? Now, okay, nod your head if this still makes sense. I just refactor into this method, run suite. Okay, you see this error, it's Swift taking one extra step to say, hey man, you actually passing this class as a value, right? And you're passing the reference to this test. Well, do .self. Like, whoa. In other languages, all of this is the same .self, .type, and the class name. So Swift Swift is very careful there. Make sure that your code is less likely to be, it help you catch more errors. Hey, so how do I run? So I'm done with running demo test. So I'm gonna run performance test. So I have this demo test here. I comment out and I say run suite performance test. All right, .self. Let's run it. Okay, you see all of my tests is taking 0 seconds. All right, let's see performance. Let's test. Who remember how to run the sum? Okay, we pass in a list. One element, and then what are we testing? Assert equal. We are asserting that maybe if you count one element, okay, let's see. You count test 1. Where's my test 1? It takes 0.001 second. Do you think how many seconds do you think it will take to take the sum from integer 0 to what? 10. It's tricky, right? How do I make sure the parentheses all match? Forgot one dot? I come from the Ruby world. And then one more parenthesis. Right. Never mind. This test failed. That's one thing, right? What test failed? Test 10 failed here, and it takes 0.02 seconds. Okay, let's make it pass first. Do you know what the result is? 1, so it's 55. All right. So then you have it pass here. Oh man, here 0.02 seconds. So because I'm doing the same thing, I'm gonna extract this test out. Okay, here I call this test n, and then pass in the word n, which is 10. And of course, you see errors. The function n doesn't exist, so I'll define function n. What is n? An integer, right? And then you pass the range from 1 to n. What is the expected sum here? So you write in here, okay, well, you're trying to test 1 plus 2 plus 3 all the way to n, right? How many numbers are there? N numbers. What is the average number? If I have $1, you have $2, you have $3, you have 4, you have 5. What's the average amount each of us have? $3, right? Because there are 5 of us and the total is 15. So the average is n plus 1 divided by 2, and there are n of them, so this is total, right? So I can say, hey, if you're testing n, maybe then you can test n plus 1 and then divide by 2. It's like that. Look, I now have test 1. Obviously, the specific code, test 10. Where's test 10? Here, passed. 3 seconds. Now I can do the same thing, test n 100, test n 1000. Okay. Any questions so far? Come on, yeah, I have one question. My question for you is, why is this test 1 over here and then test n over here, and etc.? What order is it? What order? Random, right? So Xcode 8 forces your test to be random. So unfortunately, it makes my life miserable here. Like 10, 100, and 1. Well, sometimes they sort of maybe make it alphabetical. Sometimes they make it random. So in this case, I'm lucky. I actually don't know how to make it alphabetical each time. But I want to show you this. 1 takes 2 seconds. 10 takes 1 second. Well, that's simple. This one takes 7 seconds. 1,000 take 77 milliseconds. This one takes 90 milliseconds. Now, Caroline, how many, let's not run this function yet. If I multiply this input by 10, how many seconds this will take? Why is it still failing? Caroline, can you guess? Previously declared, yeah. Come on, run the test. Okay, look, 1,000 is taking, you see, 1 digit, right? Almost 2 digit, this one. What is the next one? Can someone guess? Huh? 0.1? 0.7, because you just multiply by 10, right? What's the input size? Input size get bigger by 10, so the result get big. The time taken to run also get bigger by 10. So you can see if I write this sum function, right? One more try. If I add just one more, sum from 1 to 100,000, how long are we going to wait? How long? 10 seconds. So you think you can write that function like that and maybe this is good enough. Man, what? 2017 and you write a sum function that cannot even take 100,000 numbers? That's quite sad, right? Well, we also have some specific function like sum with some big numbers, I have to sort them. If you sum a range like this, actually you're testing a range, right? How do you sum a range? You could write a math function that just do this math and then it's always, the time taken is always 0.007. Great. So, but here we learned that our test is linear. You learned big O last week, right? So what is this one? Huh? ON. So when you just see that if it runs a small input, it takes 1 microsecond, it means you just need to increase the input by 1,000 times and already is 1 second. 10,000 times? I'm sorry, 10 seconds. It's not acceptable. So let's move on to something that increases even faster, right? You know how to see this test suite. It's very cool that I can just comment it out. I have a blank screen. I can try again. Here's my next task for you guys. Tell me, which is a final task. Take task 3. Write a find pair function. Okay, write a function that takes a list, okay, and a number, a total, okay, a total, right? A number, maybe a number, and return 2 elements in that list that add up to that number. Raise your hand if you understand this statement. If you want to move forward, let's raise your hand if you understand. If you don't raise your hand, I'm just gonna sit like this. Raise your hand if you understand this question. Write a function that takes a list and a number and return 2 elements in that list that have the total the same as number. Come on, if your right hand is too heavy, you raise your left hand. Long? Almost? So, why did I write find pair and then I delete the word? Sometimes the interviewer wants you to think of a name. It's very important. Just naming is very hard, right? So I have a function, let's say find pair. And so let's say I'm gonna, this time, I think I have a find pair function like this. And I say maybe if I pass in a list like 1, 2, 3, 4, and then if you give me 6, what should this return? 2 and 4. Sometimes the first test case you want is a normal test case, so that it's clear, right? Like, oh, you mean this, right? You're asking, you mean this, right? Yeah. Sounds good. And then so it means I'm gonna put in some extreme case. If you give an empty array and whatever number, what this should return? Empty. If you give, maybe one number, and whatever number is still even that number itself because you're asking for 2, so I just have 1. Okay. And what other test cases I can come up with? Empty, single. I need a simple. So this one would return what? The same list. I have empty, single, simple, normal, and very large. So let's get something very large. Find pair, integer from. If you can do before you do very large, just think about range. So I have from 0. If you have an array from 0 to 10, so I'll just do 1. So it's 10 elements, right? And then you pass in 19. What should this be? What should this be? So it's very important before you do anything, do this. You cheat. Here's the way you cheat. By writing this, you're writing the very obvious stuff. You write on the board or on the napkin. You cheat because you think about how to get this done. If you start solving the problem right away, you have no time. You're like, oh, actually, I'm going to iterate for I in. I cheat. By the time I write down here, then I already figure out how to solve the problem. Do parallel processing, yeah? What's the thing in Swift? Dispatch, async, and then you think about the algorithm, right? And then after you're done, you just tableview.reload data. Well, also think about this. For interview, I'm using a very simple structure like this. Empty array and 2-element array. Technically, you could return a tuple, right? A pair like this. And then you're like, well, in the case I cannot find it, it's an optional. So it's like this. But then your whole function here return either none or a thing, and then you have to deal with optional. So I don't like it. I make my data type very simple, which is empty array or 2 elements. Are you ready to write a function? Okay, so now I know that. I'm like, okay, let me show off. Right? It's actually, if you, this is practice. In the interview, you cannot do this, but this practice help you write more complicated algorithm question in the advanced interview. So for example, someone asked me to implement a tree. I write the test and I write a tree, and they're like, whoa. I don't even have to ask you if this worked. I don't have to ask you, like, can you trace, like try 1, 2, 3 and show me it works. You write the test and it works. So I'm going to do that. Find pair test. And by now you know X as test case like this. Okay. We know we just write some function, right? What is my first function? Test empty. Same deal. Test single. And then test what? Test simple. Test normal. Test, maybe you say small range. Test large range. Right? Alright, let's implement this. Well, now I can start running. You remember our run suite? And I pass in find pair test. Okay, all of this passed. Let's write something here. So maybe I know how to write things down. So assert equal, I go test case assert. So you can say equal 0, maybe, no, empty. I'm returning the empty case. If you run a function, maybe I have the find pair class. I don't know. I just name it find pair class dot find. You pass in 2 input, this like this, and it should return an empty array, right? Empty list. So I need to make sure the test passed. You can see the error right here. I'll just move it up a little bit. Then I say find pair. Then the error that say the class find pair doesn't exist no longer is an error. And I say static function find. And now I take a list of integer and a number. total is an integer, what do I return? A list, right? So normally I always return the extreme case, like boom, let's see what happens. Hey, cool, I actually have, this one, it passed. These guys, I haven't implemented yet, so I could just comment them out, I can skip them. Hey, it passed. That's a real test. Let's do a test single. Same thing over here. And then one, it's still empty. That's boring. Let's do a test. The more interesting case. Actually returning result. 1 and 2. Obviously now test fail. How do we make it work? Find this pair. So maybe return here like that. Again, maybe you can think of var result like that, and then I have to do something in here. So I say for I in list, or maybe we do for j in list, and then if I plus j equals total, then return I and j. Right? And then, well, it's complaining, I just return that. What is the problem here? You just say, okay, you should name it let blah blah. So I just return, if you cannot find, just return that. So I just delete it. But you see, along the way, I changed my code. I never have to worry about, did it work? Running the test, right? I just see whatever is input here. I read this line, 0 failures. Oh, that's cool. Just 0 failures. It works for this case, right? So what's another, you can say test normal. Maybe you can say, well, actually, I want to do something like 3, 4, and I want to, oh, wait, wrong. It should be, let's see, I expect 1 and 5. If you give me a range 1, 2, 3, 5, and then you ask me for 6, this still makes sense, right? Right? And it still passed. So that's a normal case. Let's do a naughty case. That's funny or naughty, right? What is the naughty case? I give, in this case, 10. Alright? Let's see what the error is. Failed. 1, 1, expect 5, 5. Do you think it should be 5, 5? This is another situation that I forgot to ask my interviewer. Right? I forgot. Look, did I have enough test cases? What did I forget? 2 elements must be different. So the interviewer is like, duh, I asked you for 2, I don't ask for 1. So you're like, oh shit, so my test failed. Well, it should be like this. Yeah? So how do you fix this to make it work? You're like, yeah, I know Swift. I'm pretty cool. You can actually do for I like that. Whoa, interviewers like, whoa, you know Swift, and then things work, and they don't even have to say why it works. Hey, look, all the tests passed. So then you're like, do you think it will work for a range? Let's do it for a range case, and I can maybe do a function test range. Now, when it comes to range, you think about performance again. So I'm gonna create a new one. I'm gonna not run this, and I say class find pair performance test, right? Oh my god, so long. Performance test, XC test case. And I'm gonna do this range here. Same thing, func test range 1, maybe 1. So I'll just do from 10. Come on, there's no need to do something too crazy. So 10. How do I do that for 10? I think I can write a test range n. Test range n. So maybe, in this case, let's be cool and use the argument, right? If you give n, I'm gonna assert equal. Let's find the difficult case. For example, if you give me a range from 1 to that number n, and if you give me this really big number, so I'm gonna have to test all cases, right? And it still return nil. Make sense? So how do we run this? Uh-oh. Why is it failing, guys? Ruby style again. How do I run this? I run test. Now do run suite find pair performance test. All right, what do I have? Test range. So I'm going to do this. Test range and then pass in range and 10. Make sense? So I have, where is it? Test range 10, pass. Make sense? Let's do test range 100. So it's cool, right? I passed a really big number to force my function to perform at the worst time. So I can test how slow it is. But technically, this time I cannot test how correct it is. I can only test how slow it is. So maybe I know, well, if you test between n and 1, and 1, maybe your number should be this, and maybe I'm testing between n and and n minus 1. Does it make sense, guys? So I can test from 1 to 10, then you test for the pair 9 and 10 in 19. Does it make sense? So then you're like, look how slow that is, okay? Now you tell me, can someone guess? If I put 1,000, test range 1,000. What's your name again? Done. How many seconds? How many seconds? If I put this as 1,000, how many seconds? Look, 0, 5, there's nothing a big deal there. If I do 1,000, okay, I give you 1,000. Now try to guess what 10,000 for me. Look at that one. Okay, so now let's try 10,000. Interviewer most likely just asks you this kind of thing. You may not have the chance to write all this on Xcode, right? You have to think and pretend your Xcode and execute it in your brain. But let's do the Xcode way so I can explain the point. 300, so that's 400 seconds, right? Round it up. So what is it? Like when it's at 100, what is the input size? Input size? 100. When it's at 10, input size is 10. Okay, what is the time taken? 5 seconds. If you multiply input size by 10, then you get 4. You like 4.4. So, no, come on. Someone just throw a random number. Phong. How many seconds this will take? Huh? 16 seconds? 16 seconds. Whoa, that long? Alright, let's try and run it. All started and damn. What's going on? What is big O of this guy? What is big O? ON square? What does it exactly mean for ON square? If ON square is like this, if it takes n, if for inputs n it takes 1 second, for input n multiplied by 10, it will take what? Do you think it's 100? So it's like that, and then if n, y. So I walk you through this. If the input size is 10, it's 1 second, right? If the input size is 100, okay, can it be 10 seconds? Well, you do 100 times more step, right? 10 and then 10. So technically it's like this. It will be greater than 10 seconds. It cannot be 10, but it will be this number. But it will be maybe less than 100 seconds. 100 seconds. So 100. So if this take 4, this will be less than 4, like this. That's the idea. Okay? So if you do 1,000, then it's something like this. At least you know the bounds. That's why you see this number is 365 is less than 500, right? Why? Because in this 4 seconds, there is an overhead time and the calculation time, and repetition time, right? Calculation, repetition. So if this overhead is 0 and calculation is 1, calculation is done 100 times more, so it adds to these things. But if your calculation is very fast, always 0, and overhead is like big because your input size is very big, then maybe it will be only this much. Okay, because we're running out of time. Fast. How can we fix this problem? I want to be able to solve 10,000. Right now, who guessed this now? 600? No, you asked 16. That's not too bad. It's close enough. If you guess more than 10 seconds, then you are quite correct because you know the order is, right? That's the order of magnitude. You see, it's now start to take exactly 100 times more because by now, the overhead time is the same for these guys already. Very small difference. In the first 2 small cases, overhead time may still be a little big, right? But then now all is about calculation time. What is that calculation? Doing this loop. And obviously, if you do this loop exactly 100 times more, then time it takes is more. So I can already guess. See how powerful it is. If you do it 100,000 numbers, give me 100,000 numbers, and then you give me a number, and I find 2 numbers from 100,000 numbers. How long does it take for me to find that number? I will know that it will be exactly 100 times of this. Okay? Unless this number overflow, input size too big, but we don't have that problem. The size is still okay. Input size is okay. It's just the time right now it's taking. What is the 100 time of that? 3,000 seconds. That's unacceptable. How can we make this better? So that you know about O(n) squared. So think about, some people is like, well, let's optimize this. Technically, you could do like for I in list, think of, look at this case, right? I'm gonna copy this and maybe paste it here as a, as a reminder for us how long it took. And then I try to optimize a little bit, right? Well, let's say for I in list, that's okay, but maybe I from 0 to list size, right? So maybe I have list size, list dot, is it list or size or length? Let n is list dot, is it size or length, guys? Okay. Thank you. And then here will be n. And you're like, well, I only need to do half of that. Okay, so this will be from ni plus 1 until n. And of course, I need n minus 1 here. Let's make it very clear. And obviously, they are always different. Right? Make sense? And then my test pass. And then we'll have to wait a little bit. But I want you to compare. Uh-oh. Did something fail? No failures. Oh, this is really fast. That's not good. Why is it so fast? Actually, that's not that fast. Woo. Okay. So what's going on? Why did I make it faster? Because I reduced the size, right? How much did I reduce? If you put all the numbers in a square, this is n squared. I now only look at half of the square. So it's a little faster. However, what's the big O notation of this? Huh? Can you look? From 86 to 8, it's still n squared. So when you just multiply the input by 10, it's still ridiculous. That's not good enough. So then you have to write something that's better. Here's what if you can do it in n? Did you look into how to do it in n?
Just go from first and last.
So for example, that's something we should learn this week, but let's say you call something as memory, as a dictionary. Can you do this like that? Does it work? Okay. And then, I'm just going to comment the test out. It's annoying if you run every time. And then what you do is, each time you look at a number, you remember it. So if for I in this list, okay, this is not I plus. Oh, you guys, sorry, just now it shouldn't be that fast. It should be this. I forgot. Yeah, so it shouldn't be that fast. Okay, so it will still be very similar. It's just like half times faster. Right? Yeah. So there's a efficient find, smart find. You can say, hey, I'm going to try to do this function. It's much smarter. Take the same signature, but it's like this: for I in list, smart find. And then you do memory. You keep a memory like this. It's like you're keeping track of the partner of this guy. So if the number is 1 and the total is 10, what's my partner? 9, right? So my memory is, well, I just saw this I. So maybe I saw this I already. So, okay, so you set to I. And then if, right, memory of the total minus I, if you saw it before, then you return that partner, memory total minus I, and I. Okay, so obviously we don't have time to go through it, but you can store memory I as a position of I. But the idea is that if you walk around the room and say, oh, you number 1? Okay, if I see 9, I will remember you. Yeah? So I walk, and what's your number? 2? Okay, what's your number 9? Ah, you know, I saw 1 already. Done, return a pair. So now you only walk once from 1 to n, and your algorithm is now O-N. So I just show how to use Xcode and to blast away, like master Swift better and do different test cases. You will be surprised when you handle your table view and other things. You become more senior, you will have to use Xcode unit test and other, test framework. Thank you guys.